Dear Lisa, last week I fractionated thorium-X. It went exactly as it should. Then on Saturday, Strassman
Dear
and
Otto,
I
your radium results are very startling. A reaction with slow neutrons that supposedly leads to barium. But in nuclear physics, we have experienced so many surprises.
These letters, written by Otto Hahn and Lisa Meitner, record their first uncertain grasp of the completely new idea that uranium nuclei could split in two. The discovery of nuclear fission would soon unleash awesome power. The promise of unlimited energy and the threat of nuclear destruction, changing history and affecting global politics to this day.
It all begins 1903. I obtained a post as assistant in the Chemical Institute at Marburg, staying 2 years, after which I worked under Sir William Ramsay at University College in London. From the autumn 1904 to the following summer, my work here was rewarded by the discovery of new radioactive substance, which I called radiotherium, while working on the preparation of pure radium salts. From the autumn of 1905 to the summer of the following year, I was at Physical Institute of McGill University in Canada, working under Professor Ernest Rutherford. Here I discovered radioactinium and conducted investigation with Rutherford on alpha rays of radioactinium and radioactinium. At the end of 1907, Dr. Lise Meitner came to Berlin from Vienna, then began more than 30 years cooperation. Our work embraced investigations of beta ray, their observability, magnetic spectra, use of radioactive recoil, as discovered shortly before, to obtain new radioactive transformation products. Between 1914 and 1918, my work was interrupted by the surface in the First World War, but I resumed research with Professor Meitner in 1918 and discovered actinium, the long-lived mother substance of actinium spheres. My own particular sphere was full of chemistry, and further I discovered uranium, that the first case of nuclear isomerism of radioactive kinds of atoms. My most spectacular discovery came at the end of 1938 while working jointly with Dr. Strassman. I discovered the fission of uranium and thorium is a medium-heavy atomic nuclei. My first work on these subjects appeared on 6th January and 10th February 1939 in Nature Wissenschaften. Since that time and until 1944, I continued investigation on the proof of separation of many elements and kinds of atoms.
In 1909, Hahn and I discovered radioactive recoil, finding that when an atomic nucleus emits an alpha particle, the nucleus will recoil like a coin that has fired a bullet. The recoiling positively charged nucleus can be attracted to a negatively charged electrode. We demonstrated that radioactive recoil can be used to produce elements with very high purity and collecting them to a negative charge electrode. Then, in December 1938 in Sweden, after escaping a few months earlier from Nazi Germany, I discovered that nuclear fission can produce an enormous amount of energy. Fission simply is a nuclear reaction or radioactive decay process in which the nucleus of an atom splits into two or more smaller lighter nuclei and produces gamma rays that release very large amounts of energy even by the energetic standards of radioactive decay. Fission assumed a great importance because the discovery that a nuclear chain reaction was possible led to the development of nuclear power and nuclear weapons. The radiochemists Otto Hahn and Fritz Strassman were bombarding elements with neutrons when they made an unexpected discovery. They found that while the nuclei of most elements changed somewhat during neutron bombardment, uranium nuclei changed greatly and broke into two roughly equal pieces. From Einstein's equation that the loss of melting process must have been converted into energy, in the form of kinetic energy that then could be converted into heat. Calculations made by me and my nephew, Otto Frisch, led to the conclusion that So much energy has been released that the previously undiscovered kind of process was at work. Frisch, borrowing the term binary fission, which means cell division in biology, and named
It was the year 1941. It was during World War II. It was during the height of the events. I remember everything like it was just yesterday. I remember being called by the government to work on a secret project called Chicago Pile 1. It took place in Chicago, Illinois, the University of Chicago, where we basically studied how we can make a nuclear reaction-based weapon. The idea wasn't just magically came up with by an American scientist. It was actually the idea of a German scientist. So basically there are a couple of German scientists who were working on a secret project for the Germans where they are trying to make a bomb that works using nuclear energy and a nuclear chain reaction. But they were afraid for their lives, so they leaked the information to the US government and they told us all about it. They told us about the whole project. They told us how they discovered fission in 1938 and how they even made the first nuclear chain reaction in 1933. So we had those bases to work on with the technology we had and the great minds we had in our team. By 1942, we made the world's first nuclear reactor, something that was never done before.